Welcome back to the channel. Today we're going to be talking about this thing behind me, straight out the Will Smith movie In Pursuit of Happiness. So the company Bluetti, I don't know how you pronounce it, reached out to me and asked if I wanted to test this. Basically what this is a great big solar power bank. So here's the specs on it. It's called the EB150. It's a 1500 watt hour, 1000 watt portable power station. So yeah, right up my street. You remember my previous videos way back when I actually converted this shed into a solar shed, and I used that setup there, which is like a Victron, yeah, great big battery, great big inverter. But this kind of promises to do that all in one box. So it's a pretty heavy old lump. I mean, you know, you're not going to be able to carry that for too long. It's definitely got some batteries inside there. So if we look at this thing, we've got an on-off switch, we've got ways of turning the DC and the AC power on and off. Pretty neat. USB ports on there. We've got a 12 volt socket for basically plugging car accessories in there. A USB-C, PD, whatever that means. And we've also, what's very interesting is we've got this input here for charging it, which covers from 16 to 60 volts, 10 amps. And with it, you get this rather nice looking charger, which kicks out 42 volts, 5 amps. Good quality as well. It actually feels substantial. It doesn't feel like your sort of normal Chinesey kind of stuff. So yeah, you get that, and you also get a solar charging lead as well. So you can basically just plug that in the front, MC4 connectors to a solar panel. So you can start charging this right away from a compatible solar panel. I think even though it says 60 volts here, the open circuit voltage of a solar panel can go up to about 70 volts. So this is a wide old range. So you can use tiny panels or even big panels. On the back, we've got two UK power sockets. So depending on the version you get the country relevant plug socket on there, but obviously this is a UK one. So we've got two UK ports, and both of these can handle 1000 watts. So that's 1000 watts in total, and 1200 watt peak, I believe. So let's fire this thing up. I have actually given it a bit of a charge. I think it was on half charge when it arrived. So you see a nice blue display here, gives you your readouts, which is pretty cool. You've got an input and an output of DC and AC, so you can actually see how much you know, power a device is actually pulling from one of these ports, or obviously the inverter. So let's turn the AC inverter on. Now that is now live. So what I'm going to do is try and push the limits and see if it can actually power. This is a 500 watt radiator, like an oil filled radiator, and this thing will go up to about 2000 watts, I think, like your normal kind of like fan heater. So we'll start with this one, turn it up as high as it can go, make sure that switch is off. So we'll come around the back and stick that in there, and we'll flick it on. So you can see, it's got up to, can we get this display to come back on? There you go. So we've got 520 watts, it's powering that nicely. Let's just start to heat up in a minute. So in theory, at 500 watts, this will be done in about 3 hours if we were to run this. It's a 1500 watt hour, so obviously 1500 watt hours divided by 3 is getting you about 500. So basically we are heating up this little workshop off of free energy. Well, energy from China probably. We've got a bit of fan noise from this, that's obviously just cooling down the inverter. I wonder if it's actually cooling batteries down as well, probably not, but it's probably mainly for the inverter. I think there's actually yeah, so this is the outlet, that's the inlet on the front. So this is kind of like circulating air out. Nice bit of kit, it's nicely designed. So that'd be pretty ideal if you're out camping and want a nice little bit of heat. So let's try charging up my phone as well. I've got 3 amps maximum on this USB port. Got USB-C, need to turn the DC on. There we go. See it climbing up, 10 watts. What it's going to max out at? 10 watts, so it's probably doing 2 amps into this. There you go, 45 minutes until full. So this is really cool. You kind of got a one-stop solution for everything. Charge up USB ports. I mean, you could route one of these into a hub and to have it further away. You could store this maybe like in a small camper van. You've seen my camping trailer. I've basically got, again, all Victron power stuff, and it's all been custom done with, I've had to wire everything up. But this thing would solve that in one foul swoop. You wouldn't have to have half the complication. You just literally just buy this and plug it in, off you go. This thing's getting nice and toasty. So let's try the daddy heater, see what happens. This one's got a shorter cable. Right, here we go. So, first one, I think that's just plain old cold air. So we'll flick it to the first one. We've got 1013 watts coming out of there. That's more like it. Got an error 23 showing on that DC side, so I don't know what that's about. We'll turn that off, turn that back on, try and plug the phone in again. It's only 10 watts extra, you would have thought that would handle that. Yeah, error. Okay, so maybe you can't do that when that's maxed out for some reason. So if we flick it, I mean, I'd expect this to cut out now because we're going up to 2000 watts and this can't really handle 2000 watts. So let's go up to 2000 watts here, and it's kind of limiting it to, I don't know what it's doing. It's like 1000 watts. That's a bit weird. This has gone down to a very low fan speed. It's like it's limiting rather than cutting it out. Yeah, that's strange. I don't know how that's going to work with sort of like go back to 1000 watts. Yeah, I don't know how that will handle kind of, you know, non-loads like this. This is obviously just a motor and an element. So I wonder what happens if you try and, well, there's not really going to be anything else that pulls that amount of power other than a kind of high-power battery charger. Right, we've got an error 13 just showing there. So we'll have to see what that's all about. Right, here's the manual. So let's get to the bit at the end where I think there's error codes. Here we go. So error 13 is overload protection of inverter. Check the output port, the inverter is overloaded. Turn off the AC output to recover. Okay, well we were only pulling 1013 watts or something like that, so let's try turning that off and turning it back on again. 1000 watts again, see if it does it again. So I'm not sure what that other error was, I'll check that in a minute again. But what I will say is this battery has actually been stored out here, so it is probably about, yeah, it has been about 5-6 degrees at the moment, so it could be that, you know, the battery output of the cells is reduced a little bit because of the cold, so it might not be completely fair to kind of go, oh, you know, it's not delivering what it says it's delivering. It's on at the moment. You're getting an overload protection after a little while at 1000 watts. So this is basically a 1000 watt inverter. It would be better if it was a little bit higher because then it could run, you know, one of these continuously, but you can find 500 watt versions of these, and obviously you can use the 500 watt radiator. That's if you're using it for heating. Also you could use infrared heating panels, which are, you know, be a lot lower. To try plugging that phone in again and see what happens. So error 23 is overpower protection. Check if the total output power is overloaded. Yeah, so it's definitely not going to let you do more than 1000 watts. You know, whatever it's coming from, whether it's coming from DC or AC or both. So that is how it kind of is working. No more than 1000 watts really. Yeah, it's done it again. So yeah, Bluetti, maybe raise the power limit on there, however you can do it, just so that it could potentially run 1000 watts flat out. 1000 watts is a good number. So yeah, we kind of want to be able to do that continuously. Again, this is pretty clever, this thing. I think it's obviously controlled by some sort of BMS, and then when it hits that power level, it's obviously just going, nah, no more. So they could probably just raise that. The battery's obviously inside it, are probably capable of it. So anyway, it's pretty cool. I like it so far. Let's try and charge it up with a solar panel outside. Whoa, blimey. So this is my solar trailer. Those of you who've seen the video about it before. Basically got batteries in there, an inverter, 3000 watt inverter. Victron stuff is inside. I've got a load of junk in this at the moment as I'm currently trying to move house, but basically, yeah, it's a sort of custom system. I've got a really nice 300 watt panel on the top. There's no chance of that frying this today because there's literally no sun. So I just have to unhook these, connect up this lead and plug it into the front of it. All right, error 17. Starting to need a printout of these little error codes. So yeah, error 17 is over voltage. I didn't think that panel would be too much for that. Oh well, I've got another one I can try. Let's try one of these, preferably the smaller one. So this panel is 38 volt open circuit, so this one should be right. So I ended up using the bigger panel because not a lot was happening. Not a lot of sun today, so it's not really a fair test, but we're getting about a whole 17 watts of power in on there. So yeah, as you can see, there's not really much happening there. There's a little bit of sun, but it's not much. It does seem a little bit low. Let's try and compare that to the trailer and see what the trailer's sort of bringing in at the moment. So yeah, comparable, 23 watts. This is about right. I thought that was low, but actually kind of about right. So let's go in here. So yeah, this particular one, that panel's kicking out 65 volts, 22 watts, 1.3 amps in. So probably about the same really. So this is what I was talking about with the infrared heating panel. This one's 180 watts and it easily heats up this little space, this little trailer. Yeah, so it runs on not a lot of energy. The sun's come out a bit more now, it's 33 watts. Right, so now I'm charging this boosted board, and I've also got a 500 watt heater. This is upside down. It's basically one of these things. These are pretty neat. As I was saying, you can get 500 watt heaters. This is a pretty neat one. It just goes into the wall, into like a plug socket like that. It's good for like kind of, you know, camper vans, stuff like that, if you've got the power output. So yeah, and it's pulling 420 watts. So a little bit less than 500 plus. Actually, it does sound a bit low. Stop that for a minute and just plug that in on its own. So it's a 300 watt. It's 300 watt heater, not a 500 watt one. It's quite interesting this, seeing what things pull. Right guys, thoughts so far then. I think generally it looks like a good bit of kit. It's trying to do a lot of things. It's always hard to kind of, you know, get something that will work properly with all of those things. So inside you've got a solar charger in there. Also you've got an inverter. You know, you've got obviously BMS to regulate everything. You've got USB charging, DC power output as well. So it's a lot to cram into a little box. And you know, it's about $1,000 or so, something like that. So you know, it's pretty reasonable cost for something that has quite a lot of energy in a box. I think you've got to bear in mind that, you know, you're not going to be able to pull more than 1,000 watts out of this, and that is basically split between the DC and the AC sides, it seems, at this moment. I'll probably need to do some more tests to sort of figure that out properly. But generally, yeah, I like it. It's quite compact. It'd be great for like a camper van. It would save you doing a huge great setup in one of those. Although if you did make a DIY setup, it probably would be better. It would be a lot more expensive. Because batteries, you'd probably be paying this sort of money just for batteries, just for that sort of amount of batteries. I mean, you could DIY things, you could use e-bike batteries. These days, some of the DIY e-bike batteries, you know, have around 800 watt hours, something like that. So a couple of those linked together could get you kind of a decent amount of power without too much ag and making batteries. But this is just a really tidy solution. Like, I think, you know, as a grab and go thing, if you were going camping or, you know, just to put in the back of the car to power things, just charge bikes. I've done this before, you know, just stick that in the back of the car. You know, you could even have like a small solar panel, buy like a, you know, small solar panel, put it in the back of your car. If you've got like a hatchback where you could actually have a solar panel sitting there, you could probably charge it up, you know, just passively without having to even really think about it. That sort of thing, it could be really useful for. So yeah, generally really good. I love all this stuff. I'd like to see these guys make an even more powerful one, one that could handle about 3,000 watts. Then you could possibly use it as a little kind of emergency range extender for an electric car. Not that you're going to get a huge amount of power out of one of these things, but it could get you out of a pickle. Like if you broke down and you were, you know, a couple of miles from home and you've run out of range. It's not really going to happen, but you know, it could be kind of a good thing to just have in the boot ready to go. So anyway, really good. I'm going to be using this a lot more. You'll see it in more videos and we'll kind of learn a little bit more about it as well, like everything. So thanks for watching and I'll catch you in the next one.